Assalamu alaikum. Today we'll be going over the chapter of assembly language. So first of all, we need to be aware of what assembly language really is, right? So to know that, so it is a type of a low-level programming language, and this language is closest to the computer architecture. Programming language, so high-level programming languages like C or even Python, they're not close to the computer architecture, right? And these are used directly to manipulate hardware and write programs such as device drivers, right? So this is working very closely with the computer architecture, right? And then each code instruction has an opcode that identifies the operation to be carried out and an operand. The operand is the data, and it identifies the data to be used by the opcode on which the thing is to be performed, right? So now we move on to the stages of assembly language, right? So there's two stages to the assembly language, right? So first of all, let's go over what it is. So here we can see a description of it. It is a program code written in assembly language that needs to be translated into machine code, right? So machine code is really important here, and this is done using an assembler. So the assembler is the translator here, right? And then there's two types of assemblers. There's a single pass assembler, and then there's a two pass assembler. So single pass assembler is that it puts the machine code instructions straight into the computer memory to be executed. You just put the instructions, you get your result, you get it executed right away, right? And the two pass assembler is a bit different. It produces an object code in machine code that can be stored and then loaded and then executed at a later stage. So this is kind of providing you with an executable file that you can be used later on, right? So it is kind of like a compiler in that sense, if you think about it that way. So this is what a two pass assembler does. So now we need to be aware of steps in pass one and pass two, right? So the steps in pass one, let's go over them. So first of all, you read the assembly language program one line at a time. So you read each of these statements one line at a time. Then we ignore stuff related such as like comments. So comments are for the programmer itself, right? So it does not relate to the computer running the assembly program itself, right? So the assembler does not have any use. The computer itself does not have any use while executing it. Therefore, the comments are ignored. And then it also allocates a memory address for each line of code, right? So the line of code that you're reading which is useful, you need to you need to allocate memory for it. So that is what it does, right? And then check that if the opcode is in the instruction set of the computer. So you check it. If it's not there, so you move on. If it is there, you move on. So that is what it does. So, and then it adds any new labels to the symbol table with the address if the address is known, right? And the address of the labeled instruction is then placed in the symbol table. So this is what happens pass one. So in pass two, you do the same steps as pass one, but you add a few steps. So in pass two, we'll be going over all these steps, and then we'll be coming to this that the assembly language program is read again. Once again it is read, right? Then the object code including the opcode and operand from the symbol table is generated. So the object code is generated. This is like kind of generating an executable file, right? And the symbol table is here very necessary in order to create that object code, right? And then you can save the executable file, or you can execute it right away. It's on you. So this is what happens in pass two. Pass two is a combination of pass one and a few steps added to the same procedure, right? So now we look at this table that has been given to us, and we'll go into this table in much detail afterwards, but we'll be just looking at what is provided in the exam. So this is always provided in the exam, and these are your opcodes, these are your operands, and you can see I'm highlighting each of them. So this is how it happens. There's a bunch of instructions here, right? So we'll be going into details about them later on. So as you can see, there's a lot of instructions, but you do not need to learn them by heart. You just need to know how something you need to know how they work, right? So we'll be going over how they work later on, maybe in this video, maybe in another video. So first of all, we'll be going over addressing modes, right? So these are really important, and you need to understand them even graphically if possible. I have some few diagrams along with each addressing mode in order to explain them better. So let's go over the number one. which is absolute slash direct addressing. These both are the same thing, they just have different names. And as you can see, the contents of the memory location in the operand are used. So this is your memory location, so loading 200, so 200 has this 20, and then that 20 is loaded into the accumulator. So that is how it works, right? Now we move on to indirect addressing, right? So indirect addressing, the contents of the memory location in the operand are used. So let us assume that this is LDI 200. So this is the indirect addressing's opcode, right? This is absolute addressing's opcode. So now what is being the contents of the memory location in the operand? So you have this memory location 200, so you have the content here. So the content here is 20. This is your new address, and then you go to that new address, and then the content from memory address 20, which is 50, is loaded into the accumulator. So this is how indirect addressing works. Now we move on to indexed addressing, right? So the contents of the memory location found by adding the contents of the index register to the address of the memory location the operand is used. So let us assume we have LDX, which is the operand, and this is the opcode. So LDX 200. So this means that you are adding 200 with the value of the index register, which is 2 in this case, and that brings us to a total of 202. So this 202 is your address from where you take out the 50 and then put it into the accumulator. So this is how indexed addressing works. Now we move on to immediate addressing. The value of the operand only is used. So now here is your opcode, and then there is your operand. So in this case it is LDR, and there is a hash symbol and then 200. So you're loading the denary value 200 into your accumulator. So this is your how immediate addressing works. So there's something you need to know about immediate addressing. So we'll be going over to this our symbol, this instruction set table, right? So here we can see that there is let me so we have immediate addressing, right? So immediate addressing, you can see that you have this hash here, right? So this hash is really important here because it symbolizes that it is a denary number. So like you can have hash for a denary number, you can have b for a binary number, and you can have an ampersand for a hexadecimal number, right? So this is really important in terms of immediate addressing because you're directly loading the value that has been provided to you, right? In this case it was, I think, 200, right? And then you were loading the 200 directly. So relative addressing, so the memory address used is the current memory address added to the operand. So you just need to know what it is, and symbolic addressing, a label is used instead of a value. So we'll be just going over the definitions here. I have another video in which I am attempting a trace table related to relative addressing, which would be much better to understand it rather than having some kind of an abstraction to it. It's better to go to that video and watch how you attempt relative addressing. So that would be much better off suited. So, and for symbolic addressing, you just need to know, like, let us assume you have LDD 200. So this is a normal address. For example, LDD ABC. You are doing this. This is known as symbolic addressing, right? So you do not have a number here, you do not have an address here, but you have a symbol here. So ABC is a symbol which guides you to the value, and then you perform whatever kind of addressing you want to it, right? So this is the first part of assembly language. I hope you'll be watching the other videos in which I attempt some example questions from past paper, which will be much better off than a abstract level of understanding, which will be somewhat a more hands-on experience, in, if you could say that. So thank you for watching.